Let's start. So we will start today with a really exciting agenda. We will talk about many things. We will hear about insightful presentations covering all aspects of data visualization. We'll explore everything from understanding the phenomenon we want to highlight to gathering the right data and ultimately crafting a clear and impactful visualization tailored to its audience. So without further ado, let's kick things off with our first speaker, David Bina. David is a user support officer at Mercator Ocean, and today he'll be guiding us through the NetCDF format and how to access and download data from the Copernicus Marine website. David, the floor is yours.
Okay, thank you, Marine. Do you see my screen now?
Yes, we do.
Okay, so I'm delighted to be here with you today as we explore data access and beyond. In a nutshell, I will provide an overview of the powerful tools Copernicus Marine offers for accessing and visualizing data. So my name is David. I'm working at the Copernicus Marine user support team at Mercator International. And here is the brief summary. So first, I'll present the different formats of Copernicus Marine data. Then we will see how we can explore and access the products of the Copernicus Marine catalog. And finally, I will show several methods to open and visualize data. So let's get started. As you may already know or imagine, Copernicus Marine provides a lot of ocean variables like the temperature, the salinity, the sea level, etc. into datasets, through datasets. So dataset can have only one variable and they can have multiple variables. In any case, they are multidimensional. So as we can see here on this little scheme on the right, any dataset has at least the longitude and latitude space dimensions, and also the time. And for some dataset, there is also the depth. So these are multidimensional in any case. And globally speaking, Copernicus Marine data represents a large volume of data because they can cover the entire planet. And even for regional products, it can consist in large areas and also in long time series. Some products can deliver data for decades in the past, but fortunately we can subset, so we can extract a part of each data set, and I will show you how in this presentation later on. Then in Copernicus Marine datasets, there is also the metadata, so basically the information about the dataset, so about the providers, how the variables has been measured and when, etc. And finally, these datasets are standardized, and so they are compliant regarding several conventions. And for all these points, that's why the default format of Copernicus Marine is the NetCDF. So don't worry if you don't already know this format. I will show you that it's quite simple to download and open them. So the NetCDF is the default format for original files, so the files produced by the providers. And also when you are doing a subset, this is also the default format of subset. The NetCDF format is optimized for these multidimensional data, and this is why this is widely used in earth science. On the bottom left, I have listed the main advantages of this format, but I don't have time to explain all of this in details. So I would encourage you to check our article in our help center called Introduction to the NetCDF format if you want to learn more about the format. Then on the right, I have listed other formats that you can encounter with Copernicus Marine data. The first one is the ZAR format, which is quite recent. It is also optimized for multidimensional data. And the main difference compared to NetCDF, it's that it's made and optimized for parallel and distributed computing. And also, you will find some two-dimensional data on Copernicus Marine. And I know that some of you are interested into the CSV format. So I will show you in my first demo how we can download data into CSV format. And just to mention them, we also have GeoTIFF and shapefile for really few products. Here on this slide, I have just represented schematically what I have just said. So on the left, we have a representation of Copernicus Marine data, so multidimensional arrays. And on the bottom, you can see that we can open a netcdf or ZAR format with a Xarray, which is a Python package, as a data set. And on the right, I have put data science, but I know that not all the data science data are two-dimensional, but just for the representation, I have put a 2D arrays, just to say that if you are already familiar to open some data like CSV or SQL 2D data with Pandas data frame, the equivalent of 2D data frames is for Copernicus Marine data, the Xarray dataset. So that was just a scheme. And now we are going to speak about how to explore and access data. So for the exploration, there are two main ways to do so. We can open the standalone catalog, which is called the Copernicus Marine Data Store, but also we will see that we can go on MyOcean viewers, and especially MyOcean Pro, to open the catalog and visualize data before downloading it. And then I will speak about how to access data, either via a graphical user interface or via a programming approach with the Copernicus Marine Toolbox, which is a tool developed by Copernicus Marine. And lastly, the WMTS protocol, which allows to display, visualize data remotely without having to download the data beforehand. So I will do a short live demo, but here just to explain in a few words, MyOcean Pro allows to access the catalog, of course. It allows to visualize data, to download data, and also to get the query for the toolbox when you want to download data via a programming approach. Then I won't have time to show it in this today's presentation, but there is also what we call the subsetter page, which is simply put, a simplified interface to download data, a subset of data, which is available from the products page. Then I will show in my second demo how to open data remotely and how to download data with the toolbox. And just to say a few words about the toolbox, what it allows to do, so we can access the metadata of each Copernicus Marine datasets. We can subset the datasets. We can download the original files. What's really interesting is that we can also open the data remotely with the toolbox, and all of this without quota. Because just a quick notice, via the graphical user interfaces, there is a 800 megabytes limit for the downloading, and we don't have this limit with the toolbox. So that's why sometimes, depending on our needs, we need to switch to the toolbox to download data. And I will show you it's quite simple. We can use the toolbox. Here you can see on the usage on a command line interface. So basically in the terminal, and in any language like Python or Julia, MATLAB, and others. So I will do a short demo about that just later. And a few words about the Web Map Tile Service, WMTS. Here on the right, we have a representation of what are tiles. So basically, it's dividing the Earth into tiles, some spatial ports like this. The WMTS is a standard protocol that consists of pre-rendered tiles that are stored in the server cache. So that's why it means we can remotely display data without downloading them. And basically, it's a URL, a link, and we can customize it to display the variable, so the layer we want to see. We can fine-tune the style, the zoom level, and other parameters. And it's interoperable, so it means that we can paste this link or use this link either in a web browser or in a software. And I will do it on my QGIS demo just after. So now, let me just leave my PowerPoint one moment. Here I am on the homepage of Copernicus Marine. So just to show you quickly, if you click here on Ocean Products, we open the Copernicus Marine Data Store, so the catalog containing all the Copernicus Marine products. But I will open it in my Ocean Pro, but that was just to show you that you can access the catalog from there. Then here back to the home page. If I click now on the right on Ocean Visualization, we will reach this page where we can see that there are in fact 3 My Ocean viewers. The 2 first are for beginner and intermediate users, and the last one is My Ocean Pro, and I will open it today to show you the basic functionalities to visualize, to choose a product, and to download data. So when you open this tool the first time, you have here on the left 3 layers displayed by default. You can remove a layer by clicking on the cross. So for example, here we have an animation, a particles animation for the seawater velocity, but because I know it can lag on your screen, I will remove it. And because I know that for the next presentation, Elodie and Clara will speak about the chlorophyll, I will also remove the temperature. And with this eye icon, I can show the layer. So we can hide and show a layer like this. When you are on the viewer, on the map, you can grab it, so to move left and right. You can zoom in and zoom out by scrolling with your mouse. So I'm trying to do it slowly, but when you are doing some action, it's automatically updated, so it can take some time. Here on the bottom, we have the timeline, so we can pick another date as we want. And here on the bottom right, we have the depth. So for example, if I go around 4,000 meters, we see here the ocean bottom flow. But let me go back to the surface for now. Okay, so basically when you are here on My Ocean Pro, you are looking for a product of interest, you can click here on Add Layer, and you open the catalog, the same we have seen just before. So you have here all the Copernicus Marine products that are divided into sections, like the most popular ones, the ones you have recently viewed, the new ones, etc. And what's really useful is the filters here on the left. So you can type some text in the free text search bar, you can filter with the time range or the depth, etc. For today, I will be interested into plankton because we will talk about that later. So here, for example, I can click on plankton. Then let's say that I'm interested into the global ocean. So global ocean means the entire planet. And let's say that I'm interested here in numerical models only. So for example, with these filters selected, I have now 2 products left. So on the left, we have the analysis forecast. So analysis forecast, for as a reminder, is 2 years in the past and 10 days in the future as a forecast. And the multi-year product means that it can have decades of data into the past. So for example, I will click on the analysis forecast one. When we click on a thumbnail like I've done, we see first the description of the product. So we have an abstract. Then for some products, we have use cases where the product has been used. And then we have several characteristics about the product, so the temporal, spatial resolution extent, and the variables, etc. Then on the left, you have the notifications tab, showing us the current incidents, for example, regarding this product. Then we have the data access tab, allowing to download data with different methods. And I will go back to that a little bit later. Then the contact is just opening the chatbot to contact us. And then here we have some documentation about the product. So now let me go back here and I will click on Add to Map. I will just collapse all of these to better see so here we can see that we have here all the data sets regarding plankton because I have selected plankton in my filters, but I could develop this section to see all the variables contained in these products. Okay, I will stick with phytoplankton daily today. Actually, if we are seeing this variable highlighted in blue, it's because it's one of the default layers. But if we assume that there was none to begin with, I could add it to the map by clicking on Add to Map. So I will add it once again like this, and then you can click anywhere on the map to close the window. So that's how we can select a product inside the catalog. So let me just zoom in a little bit like this. I will show you a few functionality now. For example, here on the bottom right, we have objects that we can place on the map. So for example, I can place a point, I can draw a line, and I can draw an area. So to finish drawing the area, you can press the escape button of your keyboard. And as you can see, when we place these different types of objects, graphics are automatically displayed. Just to clean a little bit my screen, I will remove, and we can remove an object by clicking here on the cross. I will just stick with my point here. So here, for example, for this point, we are watching the evolution of chlorophyll with time. The second graphic, it's with the evolution with depth, and here it's with time and depth. But if you are not interested in any graphic, you can go on this 3 dots icon and remove the graph like this. So I will remove these two graphs. And what I want to show you, so for those who are interested in CSV formats, you have here the possibility to export what we are seeing here in these charts as a netcdf, CSV, and SVG. So for example, if I click here on export to CSV, I have now in a CSV format this data available. And in fact, I will open this CSV in my second short demo right after. Last functionality, so I don't really have time to do a full tutorial, but just here you have buttons to customize how data are displayed. You can, with this button, you can select another variable contained in the product. Here with this cog icon, you could and you can select another color map, but I will stick with the default one. You can decrease or increase the opacity, etc. You can click on log to display the data as a log scale. And what I want to show you now is this download button on the left. If you didn't place any object like a point, lines, or area, as I've done just before, you can click here on Define on Map and do a rectangle. So you just draw your rectangle here, and then the coordinates are visible here. Now I can select another date range. So for example, I can just pick 3 dates for now. I could select another depth range if I wanted. And also I can click on also download here to download all the variables provided by this dataset. So I will check the checkbox. And now we have here the amount of data I'm about to download. So inside this area for this time range, depth range, and these variables, I click on download. And now I have a netcdf file on my computer. Now I will go back to my PowerPoint. So that's it for MyShone Pro. I will go back here, yeah. Now I will speak about how to open and visualize data. So basically, there are two main ways to do so via a software. So it means via a graphical user interface, which is maybe easier especially for beginners, because it requires no code skills. And there are a lot of free and powerful softwares on the web. And today I will do a short demo with QGIS, which is one of them. And then the second main method to open and visualize data is via the programming approach. So there is the Copernicus Marine toolbox. I would advise, especially for those who are starting their journey into the programming approach, the language Python, because it's beginner friendly, and obviously there are lots of tutorials and documentation on the web. But also for more advanced users, what the main advantage of the programming approach is that you can fine-tune your plots and maps the way you want via the code. So this is a list of available softwares allowing to do some visualization and map plots like QGIS. I will do my demo on QGIS today, but there are also Panoply, Snap, even the Google Earth engine. And when I was preparing this presentation, I also saw that there are at least these 2 plugins on Blender who apparently allow to open a netcdf file. So I will let you check these plugins, but that can be interesting for those among you who are experts in Blender and want to open an netcdf in Blender. And then for the programming approach, I will open a notebook where I will use the toolbox in Python, and I will open the CSV I have downloaded from MyOcean Pro just earlier, and then I will open a netcdf remotely and do some plots like we are seeing here on the right in Python, and you will see that it's quite easy to do. So let me open first QGIS. So once again, it's not a full tutorial. We have a lot of resources about QGIS in Copernicus Marine website, but just to give you an overview of how we can do so. So first, I will add a base map to see the Earth. I will change here the projection just to not have issues afterwards. So here we are seeing the planet. I'm zooming a little bit where I have downloaded data just earlier. And so first I will open a netcdf. So we have a plugin called the netcdf to QGIS that is available from the Copernicus Marine website. I go on it, and then here I can click on this plus icon, and I will, for example, take this netcdf that is the most recent one I have just downloaded. So now we can see the two variables that are in this netcdf file. And for example, I can right-click on a variable, click on Add Layers. What's convenient with this plugin is that we can pick the dates more easily than without the plugin. If I have downloaded several depths, we were about to see different depths here. So now that I have selected my 3 dates, I can click on Add and Close. I close this window also. And now we are seeing the chlorophyll for this date. So for example, I will just zoom in a little bit more. If I hiding the first layer and then the second one, we can see that this is different data because different dates. So that's a simple way to open a netcdf in a software like QGIS. Okay, so now I will just remove this group. I will go back just one moment in MyOcean Pro just to show you how we can pick the WMTS URL I was speaking earlier. So if I click on this eye icon, I open this page once again. I can go on the Data Access tab, and now on the Maps column, we have the WMTS links for all these datasets. So I will stick with my phytoplankton daily. I click on this icon to copy the URL in my clipboard. And now if I go back to QGIS, I can right-click on here WMTS, click on New Connection. I will name it, for example, Plankton, and I will paste my URL here, and I just have to click on OK. I will overwrite the existing one, and then here I have my all the connection I have in this QGIS project. So I develop all of this. I want to see the chlorophyll in linear scale, and then I just have to double-click on the same projection of the project. And now, let me unzoom. Here we are seeing the chlorophyll for this global product, so for the entire planet, but with remotely open data via the WMTS protocol. So without having to download the netcdf file beforehand. So that's it for my short QGIS demo. And now I will go on my notebook to show you how we can open a CSV, a netcdf, and start to do some plots. So I won't run each cell of the notebook to spare some time, but basically I am importing some modules. So Copernicus Marine is the toolbox. I am also importing XRA to open a netcdf as a dataset, sorry. I'm importing pandas to open a data frame, so the CSV, and matplotlib just to fine-tune some plots. So here is the CSV I have downloaded from MyOcean Pro. I am opening it with the usual pandas read CSV function. So here we have the values of the chlorophyll with time. We can check simply this data by doing this line of code with a dot plots. But also, if you know matplotlib, and I would advise you to check the documentation of modules like matplotlib or Seaborn or others to fine-tune your plots. So we can add a title, we can rename the axis of the plot, put some data. So basically what we are seeing here is the evolution of chlorophyll with time, the same that we had on MyShone Pro. So that's it for the CSV, basically. Now, I want to show you how we can download or open remotely data with the Copernicus Marine Toolbox. So I will go back just one more time in MyShone Pro just to show you that when we are building our download query here on the download canvas, earlier I have clicked on download to download it on my computer, but I can also click on automate to see and to copy the query I want to use in the toolbox. So either I want to do it in command line interface or in Python. So here I can click on this button to copy this query. And then if I go back to my notebook, I can paste it here. So here we can see that I have downloaded some file on my computer. Then I can open this netcdf. So netcdf ends with this .nc extension. I can open it with xarray. So this is the open dataset function of xarray. And here it's a visual representation of the netcdf I am opening. So basically, we can see the different dimensions of this netcdf file and the variables. So here I just have the chlorophyll. You can click, for example, on this button to see some attributes for the dimensions or the variables. And you can click on this button to see some values. And also in the netcdf, you have the metadata. I was speaking at the beginning of my presentation. And here, for example, you have the global attributes that are present in every netcdf file you will download from Copernicus Marine. But with the toolbox, so that was for the downloading. Maybe I didn't really say it's by using the subset function of the toolbox. So that's how we can download some data. But I can copy this exact same query. So I have done it here and replace subset by open dataset. So this time, this is the open dataset function of Copernicus Marine Toolbox. And using this, we are opening the data remotely. So we are not downloading it on our computer. And basically, I'm displaying this netcdf remotely open, and we are seeing the same thing. And just to tell you that with this remotely open data, we can do some stuff. We can do some post-processing and even some visualizations. So for example, here with my dataset remote, I am focusing on the chlorophyll variable. I am picking just one date. And here I am putting some minimum and maximum values for my color map. And here is the plot of chlorophyll A for the same area I have drawn on my Ocean Pro earlier. Then you can do some post-processing with a remotely open data. So for example, using the same dataset. Here I am calculating the average over space, so over the latitude and longitude dimensions. So now we can see that we have chlorophyll only depending on time and depth and not on latitude and longitude because it's the average. And then we can do the same plot as before. So I mean plotting the evolution of chlorophyll with time. So that's the same plot as before. But also, just as a reminder, when we are on a graph like this, I have shown earlier that we can export it into CSV, but I also could click on export to netcdf, and I would have a netcdf file with the average calculated inside the area. And I could totally open this netcdf file also, so with the xarray, and we will see the same plot. So that was just a quick tour to show you how easy it is to use the toolbox and how easy it is to download some data in CSV format. Then actually, I won't go to my PowerPoint. I will go back to the homepage of Copernicus Marine website just to show you some resources you can use to go further. And if you have questions, etc. So here on the header, you have the user corner, which is quite useful for because it's gathering all the services available to users. Today, I just want to highlight, you have here the Help Center. So the Help Center is a collection of a lot of useful articles. So for example, here on the search bar, if I'm typing QGIS, I will find several articles about QGIS. So I will encourage you to go to the Help Center if you are looking for information. Go back to the user corner. You have also the e-learning materials. So basically, it's providing really useful notebooks that you can get inspiration from. So you can download these notebooks and see how we can do some data visualization with Copernicus Marine data. You can filter with, for example, the tools you are using, the product you are interested in, etc. So it's a good way to have resources as well. And lastly, inside this Getting Started section, if I click on Ocean Indicators, I will open a page about ocean monitoring indicators, which are basically key variables, key indicators on oceans. And they look like charts like this. And I think that, at least for some of you, it could be really interesting to check this page, to check the ocean monitoring indicators, because these are charts and map visualization also on key variables. So you can get inspiration from these charts as well. Okay, so now I will go back to my PowerPoint. So I have already been speaking about all of this. And also, of course, I would encourage you to check our past events replays, because here in this presentation, I have been only scratching the surface. So I have done a quick tutorial on Mercator Pro, on QGIS, on using the toolbox in a notebook, etc. But there are dedicated sessions and tutorials on all of this in our past events. So don't hesitate to go on our YouTube channel, for example, to watch the replays. And last but not least, you can contact us, the user support, if you have questions. So if you are on any page of Copernicus Marine, you can click here. I don't know if you see it well. Here at the bottom right, we have the widget chat, or even in Motion Pro, you have this button to open the widget chat. You can first search for help. So basically, it's our help center. So you can search inside our articles. If you don't find the information you are looking for, you can click here on messages and ask us a question. First, you will be speaking to our AI agent, Blue, which has a lot of knowledge, and there is a high chance he can answer to your question. But if he doesn't, don't hesitate to click on Talk to Human, and then you will be reaching us, a human member of the user support. So I think that's it for my presentation. And just the last slide for information, I have put here some articles that can be interesting for these different sections for NetCDF, to learn more about NetCDF, QGIS, the toolbox, and MyOcean. So don't hesitate to check this slide after this. And now I am done. So thank you for your attention, and I will try to answer your question during the Q&A session.
Thank you so much, David. It was a really comprehensive overview of everything the Copernicus Marine Service has to offer. So just to reiterate, if you ever need more details, don't forget to check out the Help Center. It's really packed with hundreds of clear and useful articles. Also, don't hesitate to ask David questions in the Q&A tab of the event page today while he's available for you. And obviously, we will try and answer as many questions as we can towards the end of the session. So thank you again.
You're welcome.
And now that we've covered how to access the data, let's shift our focus to the science behind it. So what exactly does this data tell us? And to guide us through this, I'm pleased to introduce you Elodie Gutknecht. She's an oceanographer at Mercator Ocean International, specializing in biochemistry validation in the EB zone. And today she'll walk us through two fascinating ocean phenomena that occur in different parts of the world throughout the year. Elodie, can you hear us?
Yes.
Great. Well, the floor is yours.
And thank you, everyone. Okay. Can you see my screen?
Not quite yet.
Not?
No, not yet. Maybe try again sharing your screen.
Yes, sorry.
Ah,
Okay.
it's starting now.
Yeah, okay.
Yeah, we see your screen.
Okay, and do you see it in full screen?
Yes, we do.
Okay, perfect. Okay, so hello everyone. Today I'm going to talk to you about phytoplankton and phytoplankton blooms in the ocean. A bloom is a rapid and intense increase of phytoplankton. They are really important for a global carbon cycle, climate regulation, marine food web, and global fisheries. And these blooms can be observed using the Copernicus Marine data. So first, what are phytoplankton? Phytoplankton are microscopic algae invisible to the human eye. They live in the surface waters and they float and drift with the currents. Under a microscope, these really tiny organisms reveal an impressive variety of shapes, colors, and patterns. Here, for example, you can see a spiral of diatoms, here bioluminescent dinoflagellates, and here are coccolithophores that look like little sculptures. So they are really beautiful. But even if individually they are microscopic, they tint the color of the ocean, and this makes them to be visible from space. So in satellite images, these organisms create massive patterns forming eddies and waves or filaments that can cover vast areas of the ocean. As they flow and drift with the currents, they follow the oceanic structures that are created by currents and turbulence. But they are not just beautiful to see on a microscope and from satellite. They are also really important. They form the base of the marine food web, and they are vital for life on Earth. Why? Because they are performing photosynthesis. And thanks to a pigment, a photosynthetic pigment called chlorophyll, they perform photosynthesis. This is, they are able to transform inorganic matter, carbon and nutrients that are in the water. And thanks to sunlight energy, they build their own organic matter, their biomass. And this biomass is a primary source of energy for marine ecosystems. They are the first building block of the food web. And in addition, this process produces oxygen. In fact, they are doing the same job as plants on land. Here, I just have added for you the simplified formula for photosynthesis, but I will not go into the details. I think this should remind you your science classes some years ago. Thanks to chlorophyll A changing the color of the ocean, they are visible from space. Okay, this is an important point. And why it's so important to observe and study phytoplankton? Because they are able, they allow to absorb a part of CO2 from the atmosphere. They fixate it into their organic matter, and when organisms die, this carbon is transferred from the surface up to the deep ocean, and it will remain trapped for a long time, 100 and even thousands of years. And this process also produces half of the oxygen on Earth. So every second breath we take comes from phytoplankton. Another important point is that phytoplankton is eaten by zooplankton. Zooplankton is eaten by small fish and then large fish and top predators up to seabirds. So they are the foundation of the marine food web and they sustain global fisheries. So phytoplankton matters, and there are some phytoplankton, that is why phytoplankton blooms strongly interest scientists. Here is the global distribution of not really phytoplankton, but chlorophyll A. But remember, chlorophyll A is a pigment that is contained in phytoplankton. So it's a proxy for phytoplankton biomass. And how these figures show that is that phytoplankton doesn't grow uniformly in the ocean. Its distribution is highly variable and is influenced by factors such as sunlight, temperature, nutrient availability, and ocean currents. So there are regions that are not really suitable for phytoplankton to grow. For example, the center of the subtropical gyres that are here in blue, here. And there are other regions with favorable conditions. For example, all the coastal waters, the North Atlantic, North Pacific, the polar regions, and also the equatorial band. And in between all these areas, there are some specific phenomena that scientists are particularly keen to study. So I'm going to focus on two phenomena today, and I will describe you how they function. So the first one is called upwelling. There are four major upwelling regions in the world. They are located on the eastern edge of the Atlantic and Pacific Oceans at mid-latitude. And they are located off California, Peru, Chile, Canaria, and Benguela. And the other important phenomena I'm gonna tell to you about is called North Atlantic spring bloom. These two phenomena, they are in different regions. They operate through different mechanisms, but they are linked by similar processes, which involve the nutrient availability, which drive the phytoplankton growth. And so these two phenomena boost the phytoplankton productivity, and they are crucial for the global carbon cycle and for marine food webs. So let's now focus on the first phenomena about upwelling systems. So here are represented the four surface currents that are associated with these upwelling regions. They are called currents, and they are driven by winds. These winds blow along the coast and towards the equator. How does it function? Here, the black arrow represent equatorward winds. They blow parallel to the coastline over a long period, at least several days, up to several weeks. So as a consequence, the surface waters along the coast are pushed offshore. And so subsurface waters are pumped up to the surface to replace the surface waters that have been pushed away. And these subsurface waters that rise to the surface, they are cold and rich in nutrients and carbon. And so once these waters reach the surface, they are illuminated by the sunlight, and this allows the phytoplankton to grow. And usually they are able to grow really fast and intensively. And this provides food for zooplankton, fish, marine mammals, and seabirds. And once the upwelling, I forgot a slide. So these upwelling regions are among the most biologically productive regions of the world. They support the most important part of fisheries. They contribute to 1/4 to global fisheries, while they only occupy 1% of the global ocean area. So they are really important areas. And the most abundant fishes are sardines, anchovies, and mackerel. So as an example, I choose the California upwelling. So in these regions, we have northerly winds that blow along the coast in the direction of the equator. This upwelling is strongly seasonal. It means that during winter, the winds weaken, so the upwelling process weakened, and we have a low biological productivity in this region. But during spring, the winds become more intense. This put in place an upwelling process and a rich biological productivity and a rich ecosystems. And this can be observed in the Copernicus Marine data. If you look at this time series of California, here is the chlorophyll A over 3 years, and we can clearly see the seasonal cycle with low concentrations during winter and an increase during spring because the upwelling is starting, and a maximum during summer because the upwelling process is well in place. And then during autumn and winter, the winds are decreasing, and so the chlorophyll biomass decrease also. And this is clearly seen in this Copernicus data. And once surface waters are enriched in phytoplankton, they are pushed away by winds and they spread towards the offshore. And this form pigment-rich filaments that are sometimes visible from satellites. So this creates really beautiful features, as you can see here, with filaments and small eddies that spread towards the open ocean. So let's now move to the second phenomena I wanted to describe to you, the North Atlantic spring bloom. So it's a different process, but you will see similarity. This is one of the most significant biological events in the world ocean. It occurs every year in spring. And during in spring, phytoplankton populations rapidly increase over vast areas of the North Atlantic. They can extend over thousands of kilometers, making them clearly visible from satellites. How does it function? During winter, the length of the day is shorter, solar radiation is reduced, so this cooler the surface waters. In addition, storms are stronger, and this mix the surface waters with the deep waters. Here you can see, here we are during winter, so low solar energy, strong wind. This creates a strong vertical mixing that can reach several hundred and even thousands of meters depth. And this mix the deep waters that are enriched in nutrients. And this replenish the surface waters in nutrients. But the conditions are not really favorable to phytoplankton to grow because there are not enough solar energy, and they would be really stressed because they would be mixed over a deep depth, so it's not really favorable for them. But during spring, the length of the days are increasing, the solar energy also increase, the winds tend to decrease. So this creates a more stable surface waters. So these are perfect condition for phytoplankton to grow because waters have been replenished in nutrients during the winter. Solar energy is sufficient enough. The colon water is quite stable. So this generates a phytoplankton bloom really fast in a few days over vast areas of the Atlantic. And then after a few weeks, zooplankton, the first predator of phytoplankton, start to grow. They are eating phytoplankton. Even more, the surface waters start to become depleted in nutrients, so there are not enough food for phytoplankton to grow. And so we have a decrease of phytoplankton during summer. And this is this have a major impact on the marine ecosystem, on the global carbon cycle, because this is an important pump of carbon from the atmosphere up to the deep ocean, where carbon will remain sequestrated for hundreds or thousands of years. So this is a really important process. And even more, it drives important fisheries. And also from the Copernicus Marine data, we can see the development of this spring bloom. And Chiara will show you a nice visualization of this bloom. So here I just extracted 2 points, one at lower latitude with the dark blue and one at another one at higher latitude in the light blue. And we see that the bloom doesn't start at the same time because spring appears earlier at low latitude and appears later with a delay when we are moving to high latitude. And we can see that the development of the chlorophyll A and the maximum is delayed when we are looking at this higher latitude point. And just to finish, another typical figure we are doing as scientists to understand and visualize this bloom is this figure that is called an Moller diagram. So let me explain you this figure. To the x-axis, you have the time. So here, almost 10 years are represented. The y-axis represents the latitude. The latitude here from 10 degrees north up to 70 degrees north. So we will follow the evolution of chlorophyll A along this transect during the time. And the objective is to see the seasonal variations of chlorophyll A across the North Atlantic. So what we can see first is that below 30-35 degrees north, we are in the subtropical gyre here. And there is a low productivity almost all the year. There are a slight seasonal cycle, but biological productivity remain low, but around 30 degrees north. Late winter, early spring, chlorophyll biomass start to develop. And it doesn't, as you can see, it doesn't develop uniformly with latitude. The red colors are not vertical, but there is a slope. And this represents the fact that chlorophyll A develop with a delay when we are looking at higher latitude. So again, this we clearly show the sharp and intense bloom during spring, and then a decrease in the phytoplankton biomass during summer, a minimum during winter, and let's start again the next spring. This is a really seasonal and typical feature. It's one of the largest biological carbon fluxes on Earth. So it's an important process to analyze, visualize, and better understand. It's important for marine life and for climate regulation. And that's it. This is, as a scientist, we are classically doing this kind of 1D or 2D visualization, but in reality, this process is more 3D and even 4D. So I'm pretty sure that there are a lot of nice visualization we can do to better highlight all this phenomena. So that's it for me. Thank you for listening to me, and I hope my explanations are not complex too much and will be helpful for you.
Thank you very much, Elodie. It was really a great explanation, and these phenomena are really much clearer to me now. And I'm sure that everyone agrees that having this kind of insight into what the data represents is really valuable when it comes to creating meaningful visualizations. So thank you again. Speaking of visualization, it's time to introduce our next speaker, Chiara Phillips. I know that she's been doing a lot of research on phytoplankton blooms these last few weeks to prepare for today, and even had some discussions with Elodie to gain a deeper understanding of the phenomenon. So all of this has helped her craft an insightful and visually compelling map that I'm sure she's really excited to share with us today. So Chiara is a cartographer and senior solutions engineer at Secana, where she uses remote sensing, machine learning, and geospatial analysis to monitor carbon sequestration. Before joining Secana, she worked with NASA Develop and the USDA Foreign Agricultural Service using geospatial technology to address challenges in agriculture and food security. Her work focuses on transforming complex spatial data into clear, actionable insights that help people better understand and make informed decisions about the world around them. So, Chiara, can you hear us?
Yes, and I think you can see my screen as well.
Yes, we can, and we hear you, so
okay.
The floor is yours.
Perfect. Okay, great. Yeah, so thanks for that introduction, Marine. And yeah, as she said, I'm a cartographer, hopefully I can say that word. And I'm also an all-around data viz lover. And yeah, as many of you know, these days maps and data visualizations are everywhere. But at the same time, I feel like a lot of the choices that go behind them are often very hidden. So today I want to focus on the thinking behind effective map design. So to do that, I actually created a simple mnemonic called AED for Audience, Ethics, and Design. And so maybe some of you actually know of this device called AED, but basically you use it when someone's heart isn't working effectively, and it basically delivers a shock to get the heart back on track. And so in the same way, in cartography, AED can, like audience, ethics, and design, can help make sure that your map functions effectively for the people that need to use it. But yeah, before we dive in, I actually wanted to just show you the visualization, so it kind of puts the rest of the talk into context, but we'll also be able to see it later. So I'll just play through it one more time here. So, okay. So yeah, basically whenever I start a visualization, the first thing that I think about is the audience. So I think about who is going to be looking at it, how will they be looking at it, what formatting are they going to be looking at, and why are they looking at it, or what's the goal of my map. And so when I created this phytoplankton map, I knew that my audience would be aspiring or current data visualization professionals. I was assuming that perhaps they didn't necessarily have as deep of a background in ocean science, so I might need to add more context to that in my visualization. And I also knew that it would be shown in a webinar, so it wouldn't be necessarily interactive. It needed to be understandable at a glance, and yeah, I'd be working with kind of a slideshow dimensions. And basically, my goal ended up being how to make the North Atlantic spring bloom something visually engaging and easy to understand. And so just keeping these things in mind from the start, I was able to make design choices that would make the visualization more effective along the way. So the next part of AED is E for ethics. And yeah, I hear this phrase like the best way to learn is to teach. And for me, cartography is really a form of teaching. So it's a form of visual teaching. So as teachers, we have to ask, what do our students want to learn? So in other words, what do our map viewers need to take away or understand from our maps? So for me, this really meant diving into the world of phytoplankton, just so that I could represent the data accurately and clearly. So I was asking so many questions to Elodie and also doing a lot of research on my own, but like just learning, what is a phytoplankton bloom? Is it good? Is it bad? Is it neutral? Why does it happen? How often? Where does it happen? What are typical values? And how is it usually visualized? And why is it visualized that way? And for me, these weren't just technical questions, but also ethical ones, because people place a lot of trust into maps, despite them being full of design decisions. So as cartographers, we really have to be honest and intentional and transparent about our process and what our maps show. And so for this project, on top of doing my best to really deeply understand the phenomenon, it also meant making my workflow reproducible and transparent. And then lastly, for the D in AED, I'm going to talk about design. So yeah, basically with now having the ethical foundation in mind, the next big question is, how can you make this easy to understand? And yeah, not all elements in a map are equally important. So we need to make sure that the most critical information actually stands out first. And a lot of really strong maps intentionally guide your eye through them based on the size of things, white space, composition, color, and all of that is basically what's called like visual hierarchy in action. And actually a tip that I learned from cartographer Kenneth Field in like an Esri cartography MOOC was to squint your eyes when you're looking at your map and see what dominates your view and if that makes sense for your goals. And then a second design principle to keep in mind is accessibility, which I think is something that's still often an afterthought instead of something that takes center stage. But for me, this really meant trying to simplify my map as much as possible, removing any elements that I felt like were unnecessary, running my map through colorblind simulators like Coblis, increasing font sizes. And yeah, there's a whole world of accessibility considerations beyond vision ones that we should think about and learn about. And yeah, basically for both of these principles like visual hierarchy and accessibility, I'm not going to say that every design I've ever made was perfect or that I won't make or haven't made mistakes since, but I think they're both things that we should be checking and continuously trying to get better at. So now that we've talked about AED in more of the theory side, I actually want to walk you through my actual process for creating this visualization. So yeah, first, when I began this project, I just started off with this chlorophyll data set, and I wasn't sure what time period to map yet. So I actually just used the Copernicus Marine toolbox like command line interface in Python to download data for the whole year of 2024. And I was even able just to copy and paste from this like automate button here, which was really helpful for me. And basically from there, I just dragged and dropped the netCDF into QGIS and then was using the temporal controller to get a first look at the data. But yeah, then I decided to actually create a visualization based on when the plankton were blooming using both Python and Data Wrapper to help me decide what time range to map. And so along the way, I was learning the definitions of a plankton, when a plankton bloom starts, or what defines a plankton bloom is still debated a little bit, but we can generally say, as Elodie mentioned, that a sharp increase is a bloom. And so, yeah, this visualization helped me isolate between like the beginning of March and the end of May, since we see the sharpest spikes and highest explosions and populations for the different latitudes where this phenomenon happens within these times. And for me, I feel like this is really AED in action, because I was really making sure that I understood the phenomenon as best as I could and design in a way that didn't mislead my audience. And next, I tested several color palettes. You can see my attempts on the right, 1, 2, and 3. The first one has a very like toxic sludge vibe. But anyway, I knew that I was visualizing quantitative data, or data that was expressed in numbers from like low to high. And so it made sense to eventually use a color scheme that went from dark to light. And I also knew that there wasn't a meaningful midpoint in my data set. So I didn't have a color like white or gray or yellow in the middle of my color palette, for example. And when I was testing it out, I found that if I just use green, or I just use blue, or just one color, I wasn't really able to show enough differences in the data. And so I needed more shades to make those differences in the data more visible. And so, yeah, I ended up trying something with this second one, but I still felt like I needed more differences. So I added more of these like cerulean blue colors in my third attempt. And also, since I was using a dark base map, using brighter and greener colors for higher values of chlorophyll concentration felt very intuitive. Whereas like if it's getting a lower chlorophyll concentration, going back towards the blues made the most sense, since we're looking more at the ocean then. And let's see, what else do I want to say? Oh, and then of course, this big picture on the slide, of course, is these auroras. So actually, yeah, those pictures that Elodie was showing of auroras on her slides, when I first saw them, I really thought that it looked like the Northern Lights, and that felt very inspiring to me. And so I heard of this technique from Greg Fisk, who's a cartographer at Woodwell Climate Research Center. And he suggested sampling colors from real life pictures and seeing how that works in your data visualization. So I ended up sampling colors from auroras, and then basically adjusting based on the contrast and accessibility to find different patterns in my data. So now I had the color palette, I had the time period, I knew what area I wanted to map, and I could actually start building this in QGIS. So I knew that I wanted to also use this Globe Builder plugin to quickly add graticule and land masses and quickly change the projection in the center of my map. But yeah, basically the on-the-fly projection didn't really work well with the global net CDF. And I knew that I also wanted to create a print layout for every time step in the rasters or in the net CDF. So I created a script in Python that extracted each time step in the net CDF as a raster. And actually it was interesting seeing the plugin that David mentioned earlier, because also it looked like you can just load in the rasters as well. So I learned something cool along this webinar as well. But yeah, basically, I then just applied the symbology to one of the rasters, copied that style, and pasted it to the rest of the rasters that I had in QGIS. And then basically, I created a square print layout with the globe with just a transparent background, and then automated the print layout exports within the QGIS Python console for it to switch out the map for every raster in my layers panel. And so this way I could just export, like over 90 images into my directories. And then I designed the final layout in Adobe Illustrator. And like I said, I had these like 90 images from QGIS between March and the end of May. And I needed to sandwich them between some atmospheric effects that I created in Illustrator that are inspired by John Nelson, actually. And so I ended up writing some code in JavaScript that helped me automate the relinking of the image in my Adobe Illustrator layout. And also in that script, I was able to dynamically update the date that was shown in my visualization based off of the file name of the maps that I was linking. And from there, after I did all of those exports, I basically just dragged and dropped all of my final images into Adobe Premiere, adjusted the animation speed, and was able to export it as a video. And that being said, I also want to say that, you know, I guess this process makes it seem like it's very cut and dry, very, very linear, but actually a lot of this was, yeah, very iterative. So I was going often back to my like key AED principles, you know, thinking about, will my audience understand this? Is the message clear and accurate? Do the colors make sense? Is it intuitive? And I was really changing the visualization a lot based off of new information that I was learning about phytoplankton blooms as well. And with that, I'll let you soak in this visualization again. And I think there's also a few key ideas that I want to leave you with. And I think one of the most valuable things that you can do is to get feedback from real people. So asking questions like, you know, what is the biggest takeaway that you get from this map? What do you notice first? What questions do you have? What's confusing? Because sometimes some of the stylistic choices that we make aren't always clear to a first-time viewer. So their eye is very valuable for us as we're designing. And the last thing I'd like to highlight as part of like a crucial design process is to also be a good teammate to yourself. Because no cartographer that you look up to was born great at what they do. They all just had the patience and curiosity to try out different things and try out things again and edit when something doesn't exactly work out. But I think by working well with ourselves and thoughtfully considering our audience, our map ethics and design, I think we can create maps that help people see the world in a new way. And I'll just let you finish watching this one more time. And that's all I have for you. So thanks for listening and happy mapping.
Thank you so much, Chiara. It was super interesting and thank you again for spending all this time creating this visualization for us today, and we really appreciate it. And thank you for also sharing all these fantastic insights into your process for creating these data visualizations. This brings us to our final presentation of the day before we move on to the Q&A session. And I have some really exciting news to share with you. A really great opportunity for your work to be featured on a global stage at an upcoming ocean conference. So let's dive into the details. I will just share my screen. Okay. So first, let's start with a bit of context. So why did we launch this webinar series, and why did we want to give you the opportunity to join the United Nations Ocean Conference? We believe that scientific data should be accessible to everyone, not just scientists. Our goal was really to encourage the use of the Copernicus Marine data without making it a competition. Instead, we wanted to provide a platform for individuals skilled in data visualization to showcase their expertise, share their best practices, and exchange knowledge. It's an approach that we know is deeply embedded in this data visualization community. So what I'm going to talk to you about now is really a unique opportunity for you to be featured in the EU Digital Ocean Pavilion at the United Nations Ocean Conference, and for your work to be displayed as part of an exhibition. But not only that, the gallery we will create for it will remain available online after the conference and accessible directly from the Copernicus Marine website. So let's talk about this conference. It's a major global event, and it's all about accelerating action and bringing together governments, scientists, businesses, and citizens to protect and sustainably use our ocean. It's going to happen in Nice, in France, from May 28 to June 15, 2025, and it's really a crucial moment for ocean conservation. The goal of this conference is to drive ambitious action towards Sustainable Development Goal 14, which focuses on the health of our oceans and marine resources. So here's what UNOC 3 will focus on. It's going to focus on the stronger global cooperation for better ocean governance. It's going to focus on more funding for conservation and the blue economy. And lastly, it's going to focus on better science and knowledge sharing to inform policy. So UNOC 3 isn't starting from scratch, it's building on existing efforts and bringing people together to amplify what's already working. The ultimate goal of this conference is a real and lasting impact that ensures our oceans are protected for future generations. Now let's talk about how you can contribute to meaningful change. So at the United Nations Ocean Conference, one of the biggest spaces will be the EU Digital Ocean Pavilion, organized by the European Commission and implemented by Mercator Ocean International. Because it's going to be the official French pavilion, it holds a special significance, especially since France and Costa Rica are co-organizing the entire conference. This pavilion will be open to the public and will welcome thousands of visitors, including world leaders, European commissioners, and even Ursula von der Leyen, the president of the European Commission. So what's happening in the Engage section of the pavilion? This is where your work can shine. So the Engage section is all about educating and inspiring the public on ocean knowledge and conservation. It's basically going to be an exhibition showing the data visualizations that you're going to create to showcase in this 600 square meters pavilion. So if your data visualization is selected, it will be showcased right here on the Beyond the Surface Ocean Data Stories exhibition, and it will help make ocean science more accessible. So how will your work be showcased? It will be displayed on an interactive touch screen where visitors can explore your work and learn about it with just a tap. Some submissions may also be featured on a large screen in the Inspire section of the conference, gaining visibility during high-profile talks like the International Weather and Climate Forum, which attracts journalists and media attention. The program of the Inspire section I just mentioned is still being decided at the moment, but we want to make sure we give your work as much visibility as possible during the conference. So this is a great opportunity to showcase your work and to be part of a movement that's shaping the future of ocean conservation. So really, what I want to say today is don't miss your chance to contribute, and your data visualization could really be seen by thousands of visitors and inspire them to act and to protect the ocean. So how can you actually take part in the exhibition? It's really easy. It's just 3 simple steps. So you can find all this information on the event website on the UNOC 2025 tab. The first step is for you to explore the data available. So we've put together a selection of Copernicus Marine data sets to help you get started. Because even though David has already explained today how to download the data, etc., we're conscious that it's a lot of different variables and a very large time periods to look into. So we've kind of helped you in the data selection. But if you want to browse the catalog yourself and go through all the products available on the Copernicus Marine website, you're absolutely free to do so. You can find an ocean phenomenon that interests you and choose really the topic that excites you. So in the folders I mentioned, you'll also find the data that Chiara used to create the map she shared with us today. If you'd like to try and make your own version of this phytoplankton bloom visualization, go for it. It's really welcome, and I'm sure Chiara would be really happy to see another version of this. And don't worry, we'll keep updating the dataset folders until the end of this series, so you'll have fresh and new data to work with until the end of March. The second step is obviously to create your visualization. So it's really time to bring your data to life and remember all the tips and tricks that Chiara gave you today when doing this. So you can also use online resources, all the ones that David mentioned today. You can check out past Dataviz webinars and tutorials, and you can experiment with different ways to turn your data into images, animations, videos. And finally, the last step is to submit your work by May 20, 2025, if you want to be featured at the UNOC. So once your visualization is ready, you just need to make sure it meets the submission guidelines that are detailed on the UNOC 2025 tab. We accept formats like JPEG, PNG, GIF, MP4, MOV. So, and don't forget to include a short description explaining your work so that when people actually tap on it on the screen, they can read the short text that accompanies it and explains what it represents. All submissions will be reviewed and selected pieces will be showcased at the conference, giving you the chance to gain global visibility. And of course, you retain full rights to your work. We'll make sure to add, obviously, your name whenever your visualization is shown. The gallery, for which you can see a draft version on the screen here, will be accessible online after the UNOC event, directly from the Copernicus Marine website, and we will continue to update it with new contributions in the coming months. So we're really looking forward to seeing your contributions on here. This is, we think, really a great opportunity to make ocean science more accessible, to inspire action and be part of a movement that truly makes a difference. So for more details, just visit the UNOC 2025 tab on the event website where you registered, and we can't wait to see what you create. So now I suggest that we go to the Q&A session of the webinar today, and to do so, thank you, Gael. Gael will start sharing her screen, and if maybe David, Elodie, and Chiara, you can turn on your cameras, and we can start with the first question that was asked. And this one is for David.
Yep.
So the question highlighted in yellow-orange, for a production with 1/24 of a degree resolution, how many grid points are in the 23 by 23 kilometer polygon section, or the data taken from a center of grid cells?
So basically there are two questions. Yes. And can I share my screen to answer to these questions? Because in fact, let me share my screen here. just to showcase what I've been presenting, if you have this kind of questions, and some of you may assume I had cheated, I have cheated during the presentation, but I was asking Blue, our AI agent, to know if he can answer this question. So basically, I went here to the widget chat in messages, ask a question. And so for these two questions, I have asked our Blue assistant, for example, this question. So is the data taken from the center of the grid cells? And basically the answer is yes for Copernicus Marine data. I confirm, but what's important is that it can depend on the product. So here basically Blue has given the right answer. So don't hesitate. What I want to say is don't hesitate to ask these questions to Blue. He can answer to this type of question. And for the second one, I have just tested it here. So I have just asked the question you have asked us. And basically, I think he's right. So, but for this kind of question, of course, we can then discuss and you can contact us and we can go deeper into the question. But basically, the question was for this resolution for a product, so about 4 kilometer resolution, how many grid cells we have in a 23 by 23 kilometers polygon. And I think his arguments are valid. So basically you have 5 by 4 equals 20 grids for one side. So basically we have 5 by 5 equals 25 grid points. So I guess here Blue has also given a right answer. So to answer to you, I'm assuming that these answers to your questions, both of your questions, and just to showcase that Blue can answer this type of questions. So yeah, that's it.
Thank you. I was going to say, while you're sharing your screen, why don't we go to the next question, which is,
Okay.
Can you show again how to remotely open a file on the Copernicus Marine Service website?
Okay, so there are two ways I have shown during my presentation. But to open remotely Copernicus Marine data, I have shown one way is via the toolbox. So when you are on a script in Python, for example, you can use, let me go back here. Yeah, so basically the easiest way I would say is doing your queries in MyOcean Pro. And then you can click here on automate, as Chiara has done for her beautiful visualizations. And here you have the corresponding query. So you can copy it, but here it's the query, the exact query is to subset, so to do the download. But as I said, you can just, so let me just, for example, do the example. I have already imported my module. Here it's the new query. I just replace subset by open dataset. And this will be, if I am running this cell, remotely open data. So I can put, for example, this query in a variable like this. Oops, like this. And then, like I have done in my presentation, this was remotely open data. So this is the first method via the toolbox. But maybe you were talking about another way. Was in QGIS, but it can be in other software, of course, where I have open remotely this data, so the same products as Elodie and Chiara, remotely via the WMTS protocol. So basically, just let me go back one more time in MyOcean Pro. I will try to do it slowly. So here I have my product of interest. I can click on this eye icon. Now I can go in data access. And here I can copy any WMTS link I want. So if I want to see the CO2 daily, for example, I will change the example. I will copy it with this button. And then in my software, here I have WMS, WMTS, because it's on QGIS. It can depend on the software, of course. I right click and click on new connection. And then, I guess it was CO2. I just paste this link here. I click on OK. So it will create this new connection. Then I open it, and if it works, I double click on it. And now I am displaying the CO2, so carbon dioxide. So these are the two ways I have shown today, and I hope it answers the question. Otherwise, feel free to maybe reformulate.
Thank you very much, David. So now I suggest that we go to a question for Elodie. So the question was, do you use any software to assess nutrient content or quantify phytoplankton as well?
Okay, thanks for the question. I will try to answer to it. I'm not sure to catch all the details of this question, but maybe to make to explain you my daily work. If I'm working with model data, I have to admit that I don't use data that are distributed into the Copernicus Marine data store, because they are regraded data into regular spatial grid. And as scientists, we prefer to work on native files, the raw files that are output of our modeling systems. So, but when I'm using satellite data, I use the tool that has been presented by David to download the data, and I download them at home. We have enough space to save them, but this is just an habit. I could also directly use them as presented by David without downloading them. Then to analyze the nutrient content or phytoplankton, chlorophyll or whatever, I'm on a daily basis, I'm writing programs in Python to extract the information, make calculations, and also build my figures. And I run my Python script either from using a direct command working on Linux, or sometimes I'm connected to a big cluster, so I launch this Python script using an SBatch job. This is basically the kind of work I'm doing on a daily basis. I'm not sure if it answers your question. Hopefully, yes.
Hopefully it does, and if it doesn't, don't hesitate to maybe ask a question to Blue on the Copernicus Marine website, or contact the user support as well. Mm-hmm. Thank you, Elodie. So now we can go to the next question, which is for Chiara. And the question is, can MATLAB integrate with Python for AED, data visualization, and wavelet-based image compression for chlorophyll?
So yeah, this is a great question. I actually don't work a lot with MATLAB, so I'm not sure the answer, but maybe David or Elodie, maybe either of you have more experience with MATLAB, or?
Well, oh, sorry, go ahead.
No, but yeah, no, I let you answer.
I was about to say that, yes, you can post-process and do some stuff in MATLAB. We have some articles in the Help Center that are showing how to do some different things on MATLAB. We don't really, I mean, MATLAB is not inside our support parameter, but we still have a couple of articles to help users of MATLAB. So I would invite you to have a look to this article. You can type MATLAB in the search bar in the Help Center, like I've shown during my presentation. And if you have still some questions, don't hesitate to contact us, like I've shown in the widget chat, and we will be happy to help you.
Thank you. Elodie, did you want to add anything to it?
No, I had nothing to add. In fact, I'm not using MATLAB, only Python.
Okay.
So I have no real experience with MATLAB.
That's great,
Me
no
neither.
problem. Thank you very much. Another one for David. When selecting a polygon in data access, is there a way to determine which grid points are included within the selection, or is it possible in my Ocean Pro viewer?
I'm not sure I understand the question, but I will share my screen once again, if I may, just to show you something, because I didn't have time to show all the functionality of my Ocean Pro. Do you see my screen now? Yeah. So basically, if the question is, because in data access, the first part of the question I don't really understand, because data access for me, it's this tab. And here we don't select any polygon. So I don't really know what the question was about, but what I can say is that I will remove this area. If I do a triangle like this, and I want to download data inside this area, so I can click on define on map and click on this area. Even if this area is highlighted in blue, etc., you have to know that you will download data. The data you will download is the rectangle. How do we say? The rectangle where this triangle is in. So it will always be a rectangle, but quite recently, a new feature has been added to my Ocean Pro. Here on the bottom right, you have the import functionality. And from here, you can import some shapefile. So you have some presets. So I will let you have a look to that. So, for example, I don't know if it will work, but I can import this one. Yeah. So, for example, this is a preset. It's a shapefile. So you have a lot of presets. You will see the recent one, and then you have different formats for this import geometries functionality. You will see and have more information about this functionality in one of our articles, as usual, about the new functionality of my Ocean Pro. If you find this article, we are speaking about this functionality. So you can import some kind of shapefile in GeoJSON, yeah, and into shapefiles. So I don't know if it really answers the question, but I guess about polygons, that can be a part of the answer. Interesting for you. Yeah, that's it.
Perfect, thank you. Okay, so I guess now we still have three questions to go through. So with this one, is there a yearly average data available? I guess the answer would be it really depends on the data you're looking at and you want to work on. I don't know if David, you want to add anything to it, but
yes, of course, there are for some products yearly average. So recently we have simplified the names of the datasets. So now, like I've shown, I won't share my screen once again just for this question, but when you have the list of the datasets included in a product, you will see the temporal resolution. So it will be written daily, monthly, or yearly. So if you see yearly, basically it answers your question. It's a yearly average data. If for your product of interest, there is no data set with yearly data, but only, let's say, a monthly data, for example, you can still, in Python, do some post-processing to do the average. And I guess we have an article in our use cases collection showing that. If you don't find this information, don't hesitate, once again, to contact us, and we will be happy to help you about that.
thank you, David. I guess I see some additional questions arriving in the in the chat now. So we will answer one or two more questions, but I don't want to keep you too long because we went over time already. But I guess this is a question for Chiara. Are paid versions of Adobe Illustrator and Premiere needed to build an animated illustration such as the 2024 Bloom that you made?
Yeah, so I did use paid versions of Adobe Illustrator and Premiere for the visualization I used. But for many of my visualizations that I've made before that are animated, I've also made in Canva using free version. So I think a lot of the time I've just used free and like open source tools until I outgrow them or I can't do specific things that I want to do with it. So I would say you don't need to buy Adobe Illustrator and Premiere, but that just happened to be what I wanted to use for this project.
Thank you. And I guess for this last one, will the notebook file be available afterwards? I think what we can do is share any resource that David showed during his demos today. We can add them to the resources page on the event webpage whenever it's feasible to do so. So we'll make sure to add them on here, maybe under webinar 2 folder or something like this, and we'll make sure to share this with you. And I guess the last question that was asked is about generative AI for analyzing data, particularly for visualizing and optimizing marine data. So I guess it could be a question for everyone as well, and Chiara, for you as well, and not only about marine data, but if you tend to use AI for visualizing and optimizing data. Chiara, do you want to start answering this one?
Yeah, I would say that I am not actively using AI for actually visualizing the data. I guess you could see a lot of my process in there. A lot of what I'm doing is in QGIS and Adobe and Illustrator, but I think AI can be useful for asking questions, for brainstorming. I think we also talked about this a little bit in the previous session as well, and also the kind of ethical considerations around AI, environmental considerations. It should also be kept in mind when using it. I think it's a very new part of our field, and I think a lot of us are still adjusting to understanding like how should we actually be using this, and should we be using this. So I think it's something that's not so straightforward yet for me, but I think it is something that's a growing part of the field that we have to figure out together and on how we use it and such.
Thank you. And David and Elodie, do you have anything you'd like to add about the use of AI at Mercator Ocean?
On the R&D department, we have some activities that started some years ago now. Particularly, we are using AI to optimize the models we are running, because in the past, this optimization used to be made by hand. So we are changing parameters one by one. So this is really time consuming. So we are developing a method to optimize at least 100 of parameters automatically. We also use AI to try to emulate chlorophyll distribution without running these complex and expensive models. So this is under progress. And also, once we have long simulations, we use some tools to try to find common characteristic in distinct areas, together different biogeochemical areas with common characteristics. So yes, we are starting to use regularly AI. For visualization, not from me, maybe David, there are things done.
Nope.
No.
For visualization, no. but I just could add maybe if the question is more from a user point of view for analyzing data. I know that some AI, like the most recent one and most famous ones, can read some files like CSV, but they cannot obviously read some netcdf data. So for example, if you want to do some starting plots for analyzing data and what if there is a correlation between variables, etc., I guess you could pass a CSV for this generative AI. And in fact, we have an article, but you have to be careful. We have an article showing how we can convert a netcdf file into CSV. That's possible. And it's really one line of code in Python. But really, I want you to keep in mind that doing these conversions from netcdf to CSV is really CPU, like computing. Let me rephrase. It requires a lot of computing resources. So I would recommend to convert netcdf to CSV only for small data sets or small subsets you have downloaded. And then with this CSV, you can maybe pass it to your AI tool and see how it can analyze that. But we at the user support team, we are not using that for visualizing and optimizing marine data. No.
Great, thank you very much for all your answers. And I just wanted to answer one last question about the UNOC. It is mandatory to use Copernicus Marine Service data, but you can combine it with data from other services. But yeah, the requirement is that you use at least one set of data that you find on the Copernicus Marine Service website. So I think we are going to stop the Q&A session here just because we went over time by quite a bit already. And I just wanted to share one or two last slides with you before we wrap up. And here it is. Okay, so just wanted to say a huge thank you to all our speakers today. We really appreciated the time you spent today and before the session to prepare everything that you shared with us today. So thank you very much. I really hope you all learned at least one new thing during this session. And before we wrap up, I have a few final pieces of information I want to share. So in the Q&A section of the website, there is a poll on the right side of the screen. Please take 2 minutes to complete it. Your responses will help us understand what you think of this series so far and if it's something that you'd like to see again in the future and to make sure that we adapt it to your needs. We've curated a selection of useful tutorials, videos, and help center articles on the resources section of the event website to help you explore the Copernicus Marine data. So if you have suggestions for additional resources, let us know through the poll, and we'd be happy to include them. The webinar recording and presentations will be made available in the coming days on the event website, and you will receive an email to inform you once it's done. You can already watch the replay of the first webinar on here. And finally, I just want to say join us for the third and final webinar of this series on March 20 at 2 p.m. CET. We'll explore more scientific topics like marine heat waves, for example, and Julian Hoffman-Anton, data science and visualization designer, will also showcase a visualization he created using Copernicus Marine data and share valuable tips and tricks. This last session will wrap up the series, so don't hesitate to join and ask all your final questions. Thank you again for joining us today, and we will see you in a couple of weeks. Thank you, everyone.
Bye-bye.
Thank you. Goodbye.